This was the methodology that we taught you yesterday, and today we have taken you through the entire scheme. Okay, now you have assumed some envelope length. Okay, what number did you assume?
Less than 4.
No, that was the requirement, but in doing the calculation,
3.5.
3.5, please tell me the unit. 3.5 meters. Okay, so you assume length to be 3.5 meters, and then you went through this entire loop of all the calculations. Finally, you won. So did you reach the requirement? Did you meet the payload requirement?
Yes, sir.
For both the gases?
Yes, sir.
No, that is not true.
No, sir. For hydrogen, we met the requirement. That is
Yeah.
clearly we met the requirement.
Yeah, we did not meet the requirement for helium. Helium payload with helium was lower than required, and the payload with so let me ask you a question now. Just try to answer this based on your understanding and intelligence. This is not to do with LTS systems. So how is it possible that I could get an answer which is exactly matching with the required payload? I mean, did I know in advance that 3.5 meters will be sufficient? How did I get it? Do you understand the question, my friends?
Yes, sir.
So how did I know in advance that 3.5 meters will give me almost 250 grams of payload after going through all these calculations one by one? So do you think it is possible?
Sir, maybe due to experimentation.
No. You are giving too much credit to me. No. I did not see. Whatever experiment you do, you cannot have such an expertise, I think, unless you have artificial intelligence or if you use machine learning tools, that I give an envelope length and it will perfectly match the requirement, because there are so many things in between. Okay. So basically, I did this because I have a spreadsheet to do these calculations. And in a spreadsheet, I can keep on changing the input to get the output. So if you have to do this calculation manually, how much time will it take? See, the whole day has gone and you have done only one calculation. Okay. For example, if you have taken the gas as helium, the answer is payload requirement not met. So that means you'll go up and change the envelope length. So 3.5 is not enough. What will you do? You cannot go beyond 4 meters. So what will you do? Please answer my question. Is the question clear to you? Should I repeat the question?
Sir, please do repeat the question.
My question is, we have found that if we use helium as a lifting gas, the assumed envelope length of 3.5 meters is not sufficient because payload is below the required payload. So therefore, in this flow chart, is payload requirement met? The answer is no. So the action is change envelope length and go back. So what will you do? How will you change this envelope length? How much will you change?
Length should be more than 3.5.
Yes, and it should be less than 4.
Yes, sir.
What should it be? What will you try?
.8, 3.9.
Okay, how did you get this number 3.8? Just between 3.5 and between 3.5 and 4, correct?
Yes, sir.
and you calculate it. Suppose you take 3.8 and you again do the whole calculation by hand, and again you find that the payload requirement is not met, then what do? Repeat for 3.9, then 3.95, then 3.98. So that will take too much of time. So we don't do this like this manually. We do it using a computer. Correct? Now, next thing that we do normally is, so these are the final parameters of the airship, right? All of you remember these values, that we have found that the airship is feasible if you use hydrogen with a volume of 1.403 cubic meters. A 3.5 meter length for NPL shape gives you the payload of 250 grams. So now the next thing that is very important is what is called as the sensitivity analysis. Sensitivity analysis is a very, very important aspect of any design exercise, in which we have to investigate what if scenarios. That means what happens if we change something. For example, what if the length is increased to 4 meters? What will happen in the calculations? If the length is increased to 4 meters, what will happen in the calculations? What will you get?
Shape and volume all should be changed.
Okay, I'm not changing the shape. I'm not changing the volume. I'm just changing the length to 4 meters. Of course, volume will automatically change. So maybe you will get payload requirement met, maybe not. We don't know. Correct?
Yes, sir.
Similarly, what if the lifting gas is changed to helium? We already know the answer. The answer is it will be lead to infeasible. Now we have used NPL shape. What if we change the envelope to GNVR? What if we change the envelope material? Like that, there can be 100 such questions, and a designer would like to know the answer. So to do those answers, we do what is called as sensitivity analysis. And as Shashwat mentioned, I will now show you the spreadsheet which can be used for sizing of an indoor airship. This spreadsheet was created by Shashwat. Okay, so we have to thank him for creating this spreadsheet. So there are two. You are able to see my screen, na?
Yes, sir.
So I will now don't get bogged down by so many numbers. Just follow one by one what I show you. So first of all, you can notice there are two sheets inside this spreadsheet. One is called as NPL, other is called as GNVR. What are these two? Can someone tell me?
Envelope shape.
These are two envelope shapes. Are these the only shapes? No, there are many shapes possible. Okay. So let us look at NPL shape, which is what we have used in our example. So here in a spreadsheet, now how many of you are quite familiar with Excel spreadsheet?
So almost everyone.
Yeah, but unfortunately, almost everyone is not speaking. This is my major complaint to this group, that only 2 or 3 people I can make out their voice. Everybody else is just silent. And that is not really a good thing. Okay. Anyway, it is up to them. I mean, we cannot force anybody to talk. Okay. So in the column number A and B on the top, I have payload 0.25 kg, velocity 8 meters per second, endurance 0.25 hours, which is 15 minutes, altitude 0 meters, and delta ISA 0. Delta ISA 0 means I am operating under ISA conditions. The temperature is not more or less than what happens in ISA. Now, assume parameters. The one is the topmost parameter is the length, and the next parameter is the shape. Then we are using lifting gas. Either we use hydrogen or helium. So I have just put a system here that if you use hydrogen, then it will be 1. If you use helium, I have to enter 2 here. Okay. So now please tell me, if you have listened very carefully, right now what is happening is, look at column number K and L. So this is the total mass distribution. Correct?
Yes, sir.
Yes,
Can you
sir.
please match these numbers with your calculations? Are these numbers matching with the calculations, or is there any change?
Yes, sir, match.
They're all matching, right?
Yes,
Yes,
sir.
sir.
That means payload is 252.51 grams, which is 2.51 grams positive excess. That is why the green colored band. Okay. Now, if I change lifting gas from hydrogen to helium, what will happen to the excess payload?
It will go in negative, sir.
How much will it go? You should know this because you must have done the calculation. Shashwat, can you help us?
$136.
That is payload. But what is the excess payload? Negative how much? It will be 250 minus 136.
Sir, 114.
Minus 114.
Minus
Okay.
114. Yes,
So
sir.
if I change lifting gas from hydrogen to helium, we should get minus 114 there approximately. Let us see what happens. So keeping everything else same, I am just changing the gas to helium and I get minus 112.68. Payload available is 137.32. Correct? So this is the beauty of the spreadsheet. Once you make the spreadsheet correctly, then any change, you can get the answer instantaneously. Now, please tell me, those of you who know Excel, how do I find the length in column number E2? That means, how do I find the length in this column such that the excess payload becomes exactly equal to 0? Can someone tell me a method for doing that? I want payload available to be exactly 250 grams. So therefore, I want excess payload to be equal to 0. And for that, everything else is remaining same. I can only play with the length. So how should I do it? What should I do?
Increase it.
Increase what? Increase what?
The length.
How much?
By point.
5.3.
By 0.3. How did you get that number? Arbitrary, right?
Yes, sir.
Okay, let us try 3.8. Now you have positive payload. Payload is plus 308 grams. So that means the answer is less than 3.8, but more than 3.5. Now what do you do?
3.7.
3.7, okay. 3.7 minus 6.27 grams. That means it is more than 3.7, less than 3.8.
3.75.
Yeah. So when will you stop?
3.9.
No, 3.9 will be more, na, because 3.8 itself gave you. Now also you are getting positive payload. Again, you are getting 24.94 grams more. So what you are saying, what you are doing right now is actually called as Ghodagiri in our IIT Bombay language. That means you keep on like a horse, keep on doing things one by one, one by one. Is there a smarter way of doing this? Can I get exact length which will give me excess payload equal to 0 or almost 0?
We can assume something and like cross multiply and get the unknown variable.
don't give me any gyan, give me a method. You have a spreadsheet in front of you, tell me what to do. Because some of you said make it 3.7, I did it, then I made 3.8, then I made 3.75. I cannot keep on doing it endlessly till the evening. So I need a way, a smart way by which I can get exact length required so that excess payload is equal to 0. So those of you who know Excel, those who said yes, we know Excel, almost everybody knows Excel. Can you tell me, do you know about this feature in Excel?
No, sir. I don't know
So I will teach you a very interesting thing today, and that is called as goal seek. Have you heard of this term called goal seek?
No, sir.
No, sir.
So there is a tab called data on top. Can you see that?
Yes, sir.
In
Yes,
data,
sir.
there is one document called what if analysis. So what it does is try out various values for the formulas in your sheet using scenario manager, goal seek, and data table. So I will teach you today what is meant by goal seek. So go to goal seek. Now in goal seek, we are saying that I want you to set a particular cell to some particular value by changing a particular cell. So so this particular cell is what we want to set. That means L10 is the place where we want to get something. What do you want to get here?
0.
0 point. I'll just do it like that. Okay. And which cell do you want to change?
E2.
Length.
And then you say okay. So Excel does this automatically inside. And if it is possible, it gets the length which will give you exactly 0. So if you like it, you say okay. So that means a length of 3.5 is okay for hydrogen, but a length of 3.71 is needed if you want to use helium. This is the first thing that I wanted you to learn today, the usage of goal seek feature. Now, let us say that, okay, I am going to just increase this to 3.7. I'll make it 3.75. So I get 24.94 grams excess payload. Now I want to see what is the effect if I change the payload. Or any other parameter. So suppose the same airship, you have already built the airship, the length is 3.75 meters. Now this airship is not operated at delta ISA equal to 0, but in a hotter atmosphere with delta ISA equal to, let's say, 10 degrees. So what is meant by delta ISA equal to 10? What is the meaning of that? What is the meaning of delta ISA equal to 10 instead of delta ISA equal to 0?
We are taking standard temperature at 10.
No.
Sir, there is a change in ISA by 10.
Correct. So if the ISA value at sea level is 288.16 degree Kelvin, we will take it as 298.16 degree Kelvin. Is it possible to have a place like that? Is it possible to have a place where ISA plus 10 is prevalent?
Sir, yes, sir.
Yeah, there could be so many places on the earth where temperature at sea level is not 15, but 25. Mumbai is one of them. In Mumbai, so many times you find temperature 25 degrees. So now please tell me, if I change this delta ISA to 10, what do you think will happen to the payload? Will this excess payload decrease, increase, or remain same? This is a typical what if scenario.
Remains
What if,
same.
what if I fly the airship at a hotter condition? So you said less, right? What is your name? Shruti, I think. Na?
Sir, remains same because of payload does not depend on ISA.
Why do you say that? What does payload depend on?
Volume and surface area.
What about density of the lifting gas? When you change from hydrogen to helium, why did the payload change? If it depends only on volume and surface area, then why should it change when you change only the gas? If you have listened very carefully
Yes,
to our
sir.
presentation, please tell what will happen.
Yes, sir, it will change.
Yes, sir.
Ambient density will decrease.
Decrease or increase?
Decrease.
Decrease, sir.
Decrease. Increase temperature, decrease density.
Sir, it is gas, right? So if it increase the temperature in the gases, it will loosen up.
So what will happen to the excess payload?
Excess payload will decrease.
Excess payload will?
Decrease, sir.
Okay. How many of you say it will decrease? Anybody who says it will increase, what is the logic of decreasing? Why will it decrease?
Because of density.
But density of air also will change. Na? If it is ISA plus 10, it is ISA plus 10 for both hydrogen inside and air outside.
Yes, sir.
So then what happens? So delta ISA, suppose I make it 1000. Now I am in some other planet where temperature is equal to 1000 degrees. Still there is no change. So this change is wrong. No. This notice is wrong because unfortunately in this spreadsheet I have not coupled the change in delta onto the lift calculation. So this is not working. This spreadsheet is not perfect. I have to do that because notice the density of the gas is not changing whatever I do. Okay. Now tell me, suppose I change the fin GSM. Fin is how much? 250 GSM right now. Correct? Yes or no?
Excuse me, sir.
Yeah.
Sir, actually, the screen is getting a bit blurry, sir. It is getting okay now. Yes. It is getting a bit visible now. Yes, sir, 250 GSM.
250. Okay. So the fin GSM is 250. Suppose I make it 260. What will happen to the excess payload and why?
So first it will give destabilizing moment.
This is about the fin weight, not fin area. This is GSM. The weight of the material used to make the fin is more by 10 grams. Nothing to do with stability, nothing to do with controllability. Please tell me what will happen if I increase the fin.
Payload should be increased.
Payload will be increased. That means excess payload will be increased. That is what you are saying.
Yes, sir, because other values also changes.
Which value changes? Sorry.
So in total mass, fins weight will be changed.
So will it become more or less?
Sir, payload available will decrease as well as excess payload will also decrease.
Yeah. So don't talk about payload available right now, because excess payload itself is one parameter which we are looking at.
Yes.
Okay. So if I make it 260 GSM, I will get only 19 grams excess. If I make it 270 GSM, I'll get 13 grams. If I make it 300 GSM, I get negative. That means I have a margin in the fins that I can go from 250 GSM to maybe 290 GSM, keeping everything else same. I will still not get negative value here. So this is called as investigating the what if scenario. Change in something, what does it change? That analysis is called as a what if analysis. So now let us try to see the effect of change in some other parameters also. So now please tell me, which parameter will affect maximum the excess payload? I think it will be envelope GSM, because envelope is a very large part. Envelope is the heaviest part in this airship, 665 grams. And if the envelope GSM is increased from 65 to, let's say, 150, there will be massive negative lift. The lift is only 1.8 grams. The net lift is only 1.8 grams. So it's a very, very bad. Okay. So this was 65. Let us make it 70. Oh, it goes to negative. So this is what I meant by investigating what if scenarios. So provided you connect them properly, effect of each of them should be considered on everything else. Then you can do this analysis and get the benefit. So is it clear what I am doing here?
Yes,
Yes,
sir.
sir.
So tell me now, what do you want to play with? What do you want to increase? Let me ask you a question. I want to decrease the excess payload. What should I change?
So
So now please tell me, what is the effect you would like to check? You have to decide what do you want to see. And there should be some logic in your argument. Why do you want to see something?
sir, it is blurred.
Okay, so if it is blurred, then I really cannot do much.
Now, okay, sir.
Okay. So it's up to you, friends. You have to decide what parameter you would like to change. I will change it and then we will see the effect of that.
L by D ratio.
L by D ratio. Suppose I change this number from 0.25. I make it, let's say, 0.4. What do you think will happen? Just think about it. When L by D is when the D by L is increased, that means now it's going to be more diameter and lesser length. Do you think the volume will go up or reduce? What do you think? I made it 0.4. I want you to tell me. Okay, let me just do it and see the effect of this. When I make it 0.4, I get such a large excess payload. That means if I reduce the L by D to 2.5, length is still 3.75. L by D is 2.5. That means D is increased. Look at the volume. The volume is 4.418.
Volume is same.
Okay, so L by D has a huge effect because this is going to change the shape completely. So we'll go back to 0.25. So like that, you can see the effect of change in various parameters on the final output. And that is the essence of the sensitivity analysis. So now I am going to play with this spreadsheet only based on whatever you tell me. I want you to think and tell me, sir, try the effect of this, try the effect of that, and I will show it to you. Nobody has any questions or suggestions? All right, if there are no suggestions, no questions, then we should stop our spreadsheet and then we should close.
Shape of the envelope.
Okay, what shape do you want?
So GNVR.
Okay, so I have a spreadsheet, so I have copied everything in that, except I have inserted the GNVR formula. So do you want to have the same length, 3.75? So we go to GNVR, and interestingly, for the exact same conditions, if you use GNVR shape, then 3.5 meters is giving you excess payload of 285 grams. Whereas in NPL, if I make 3.5 meters, it was giving negative of 112 kg. Payload available will be only 137.32. And here, if I make the GNVR shape of this volume, so why has the GNVR shape given you better payload. I want to know why.
Because of gas.
Because of gas.
Sir, could you please take the page to the GNVR
Yeah.
Excel sheet?
Yes.
Sir, there is a difference in volume, sir.
Yeah, there will be. GNVR shape of the same length has a higher volume than FPL shape. This is common sense because GNVR shape L by D is 3.05 and NPL shape it is 4. So the diameter is 3 times the length. Their diameter is 4 times the length. So if the length is same, this fellow will have more diameter and therefore it will have more volume. If it has more volume, it will have more weight, but it will also be subtractable. So the department will feel that if the same shape is coming, it is going to give some benefit in structures lab. The same benefit can also be done in some other lab. That is how it works. So basically, shape is very important. You must have seen the same envelope of 3.5 liters. It will give you. Now, suppose I change this. Now, this is with helium. Suppose I change it to hydrogen. What will happen? Will the excess payload go up or come down?
Go up.
By how much will it go up? I don't know why nobody is responding to my question.
Sir, screen again.
Forget about the screen. Can you answer this based on your understanding? In the GNVR, I am getting 285.8 grams of excess payload if I use helium. If I change it to hydrogen, what will happen to the payload?
It will increase.
By how much will it increase? So the payload will increase by approximately 7%, 7.25%, approximately. Let's see, I changed it to hydrogen. Yeah, 469.10. So the payload was earlier 719.1. If I make it helium, it becomes 535.8. Okay, anything else you want to try? So this way we can play with the numbers and try to see the effect of that on our parameter.
Sir, here can you make the L by D 2.5 for GNVR?
I can, but it will not be GNVR. See, GNVR is a shape with L by D equal to 3.05. But let me see. Suppose I manually put, oh, I can't change here. I have to change here only. So the value of phi, which is 0.3278 for GNVR, what do you want to do to that?
Make it 0.25.
0.25. So payload will become minus 182, excess payload. Look at the volume, 0.990. So this is what I wanted to tell you, that lot of what if scenarios are possible if you have a spreadsheet like this or a code with you, and then you can use it to design your airship. Okay. So with this, I would like to come back to the presentation now. Oh, that's it. We have come to the end.